So imagine you need to update your database before the application start, and the task should run only once. And that's exactly what Kubernetes Job is for. So in this video, we will cover what is Kubernetes Job, how it is different from deployment, how does it work, and we will also see some of the examples for the Kubernetes Job on the real Kubernetes cluster. So let's get started. So what is Kubernetes Job? A job is the Kubernetes workload that used to run the task that need to complete and then stop. So unlike a deployment where pods are meant to keep running continuously, but a job run a pod until it finishes successfully. It also tracks whether the task is succeed or failed, and it retries automatically if the task failed. Examples include database backup, batch data processing, report generation, sending a bulk email, and one-time database migration. Now let's see how Kubernetes Job is different from deployment. So both manage the pod, but they behave differently. So in the deployment, the pod run continuously or forever, but in the job, pod run at once and exit when the task is done. In deployment, if the pod crashes, it restarted automatically to keep the application always available. But in the job, if the pod fails, it retries up to a limit and then mark it as failed. In the deployment, success and failure is not really tracked. App is just running and not running. But in the job, Kubernetes track completion state, succeed or failed. In the deployment, it is used for the long-running services like app services or APIs, but in the job, it is used for the short-lived or one-time batch task. Now let's understand how Kubernetes Job work behind the scene. So when you run kubectl apply and the file name job definition is sent to the Kubernetes API server. And the API server further validate the request and store the job definition in the cluster. Next, the job controller continuously watches the new job, and when it detects our job, it creates the pod to perform the task. The Kubernetes scheduler then assigns the pod to the suitable worker node where the container start running. The container executes the command defined in the job, such as processing the data, taking the backup, or running the database migration. So once the task is finished, Kubernetes checks the exit code written by the container. If the container exit code is equal to 0, Kubernetes considers the task is successful. If the container exit code is equal to non-zero, then Kubernetes treat as a failure, and instead of restarting the same pod, Kubernetes Job create a new brand pod and retry the task. Kubernetes continuously creating a new job until the task is finished, and if all retry attempt fail, the job is marked as a failed. Now let's jump into the hands-on. So let's open the killercoder.com, select the Kubernetes playground, and wait for the environment to load. And once it is loaded, let's verify the cluster. So our control plane and worker node are in ready state. So first let's create the basic job that simulate the basic task. So let's first create the YAML file for the job. Copy this YAML file and press -i and paste the YAML file. So in this YAML file, we need to understand the important fields. So first we have a completion is equal to 1, and that means one successful pod is required to complete this job. Second, we have back off limit is equal to 3, and this means if the pod fails, Kubernetes retry the job up to 3 times before making it as a failed. Third, we have a restart policy is equal to never. This means if the container exit, Kubernetes does not restart the same pod. Instead, if a retry is needed, the job controller create a new pod based on the backlog limit. So let's save the file and execute the file. So let's execute the file and watch the status. And you see the first status is equal to container creating, and then our job is running. And finally, after 10 seconds, our job is completed. Now let's check the job. And you will see completion one by one, that confirming task is completed successfully. Now let's clean up the job. Now let's jump into the second demo and let's create the file for this. Press -i and paste the YAML file. So in the real application, job read the customer order from a file, process them and update the inventory database and generate the processing summary. So for this demo, we are simulating those steps with the simple Linux command. Now save this file and exit. Now let's apply the job. And let's check the job. Our job is not completed yet. Now let's check the pod. Our job is still not completed. And finally, our job is completed. Now let's check the log. So to check the log, we will use kubectl log and the pod name. Here we have a pod name. So we will copy the pod name from here and we will paste it here. And you will see the output something like this, which we have mentioned in the YAML file. Now let's clean up the job again. Now let's do the hands-on on the third Kubernetes job that is running multiple pods in the parallel. So first let's create the YAML file and press -i and copy and paste the YAML file. So this YAML file is similar to the first example, but we introduce a one new field called parallelism. So in this YAML file, we have a completion is equal to 5. This means 5 successful pod completion is required before the job is marked as completed. Then we have a parallelism is equal to 2. This means Kubernetes can run up to 2 pods at the same time. And then we have back of limit is equal to 3. It means if a pod fail, Kubernetes retry job up to 3 times before marking it is as a failed. Now let's save and exit the file and run this file. Now let's watch the pod and you see our pod is running. So as you can see here, 2 job is started and then after few seconds job is completed. And once the initial 2 job is completed, again 2 job has started here and it is completed after the few seconds. And then finally the 1 job has started and then it also completed after the few seconds. And this is what we have defined in the job YAML file. So let's try to list the job as well. And you see our job is successfully completed. Now let's do the cleanup. So let's quickly recap what we have learned today. So a job run the task once and exit after the completion. So unlike a deployment, a job stop after completing its task. If exit code is equal to 0, it means succeed, and non-exit code is equal to failure. Parallelism run the multiple pods at the same time. And Kubernetes Job is used for the batch processing, backup and database migration. And below we have a few comments that we have used for the demo. So that's everything about the Kubernetes job. So in the next video, we will learn about the Kubernetes cron job. If you have any questions, feel free to ask in the comment below. Thanks for watching and I will see you in the next video.